Welcome viewers to Noble Tutorials. Now, in this question, we are going to still be looking at variations, and this one is under inverse variation. Okay, now the question says solution. The question says the weight of a body varies inversely, that is, the weight of the body W varies inversely as the square of the distance. Varies inversely. Inversely is 1 over the square of the distance. 1 over the square of the distance, let's say d square, not square root. Now, if you want to analyze, you now have that W is equals to K times 1 over d raised to the power 2, and W is equals to K over d raised to the power 2. Now, that is the expression. Now, the body weighs 80 Newton. The body weighs 80 Newton. That is, the weight is 80, and the radius is what? 6,400. Now, first of all, you need these parameters for you to get your K, the constant of the variation. You have W, which is 80, is equals to K over 6400 raised to the power 2 over 1. You cross multiply. When you cross multiply, you have that K is equals to 80 times 6400 raised to the power 2. Let's see what it gives us. 6400 raised to the power 6400 times 6400. We'll be having 40960000. And when you now multiply it by 80, you're having a huge number. You're having 3,276,800,000. Now, this is the value of the K. Now, you have the first question says obtain an expression connecting the weight of the body and its distance from the center. So, obtaining an expression, we are having W is equals to K over d raised to the power 2. Obtaining an expression means just take the value of the K and substitute in the equation, and we are having W is equals to 3,276,800,000 all over d raised to the power 2. Now, the second question says calculate the distance of the body of 20 newtons from the center of the earth. So that is the second question. The second question, now you are being asked to calculate the distance. So making distance subject of the formula, you have W is equals to K over d raised to the power 2 and over 1. You cross multiply, you have K is equals to WD square. So divide both sides by W. Divide both sides by W, and you'll be having that d square is equals to K over W, and d square is equals to your K is 3,276,800,000 all over your W. Your W is now 20 Newton. So when you divide this by 20, when you divide this huge number by 20 divided by 20, you have 3,276,800,000 divided divided by 20, we have that is 163,840000. Now, this is now square root of 163,840000, because when square crosses the equality sign, you change it to square root. So when you have this, you have that the square root of 163,840,000. The square root will now be that d is equals to 12800 kilometers. That is the value of d. Now, the third question says calculate the weight of the body, which is 1,600 kilometers above the Earth's surface. Calculate the weight of the body, which is 1,600 kilometers above the Earth's surface. So you still have. Now, the question says calculate the weight of the body, which is 1,600 kilometers above the Earth's surface. Above the Earth's surface. So we have that from using our initial equation that W is equals to K over d raised to the power 2, and your W is what you are looking for. Now, the question says 1,600 kilometers above the Earth's surface. So the total distance above the Earth's surface now, the total distance will now be 1600 plus 6400. That will be total distance. So your D is now 8,000. Your D is now 8,000 kilometers. So you have that your care is already 3276800000. How many zeros? 1, 2, 3, 4, 5. 1, 2, 3, 4. Okay. All over your D is now 8,000 raised to the power 2. So you have W is equals W is now equals 3276812345. All over. This raised to power 2 will give you 64000000. So when you start dividing 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So you are left with 32768 divided by 640, and we're having that your weight is 51.2 Newton. Your weight is 51.2 Newton, and that is the answer for this question. This question is coming from NATO 2006 question 10B. Thank you very much.